Okay, hi everyone. Thank you for coming to the Geocoder talks. My name is Randy Meech. I'm the CEO of Mapzen, and I'm here to talk about our new project, Pelias, which is an open source geocoder using Elasticsearch. And I'm really grateful for the format of these talks and that there are several new attempts at this, because I think it's a really important problem. It's really large, and it definitely needs a lot of different approaches and experimentation. So first, a bit about what we're doing here. Mapzen is a fully open source mapping company that builds and supports open software and data. At the moment, we're working on services for mobile apps using OpenStreetMap and other open data services. So what we wanted to do was build a demo of what a professional mobile app mapping application would look like using just open data and software with no proprietary parts at all. So the rules are we can contribute to existing projects or build our own new ones. And a few people here, we have an Android APK. It's not launched, but I think Serge is actually our biggest fan. So if anyone wants to use this, see one of us afterwards and I can send you the APK. So the biggest problem that we're facing here is geocoding. Like, when I'm talking about the mapping app we built, we're using OpenScienceMap, the team we've met here, which is great. We're also doing some vector rendering, which Brett Camper, my co-founder, was talking about yesterday. The big problem here is geocoding. As you use the app, you can really see that it sticks out. And I gave a similar talk at State of the Map US. Peter Batty then spoke about it afterward, wrote about it afterwards, saying another historical weakness with OpenStreetMap has been addressing geocoding. There's also quite a lot of effort going into this area, but it would seem not as much progress as we've seen with routing. We're also using some routing engines like open source routing machine, which works really well. My take on this is there's currently no production ready, open source geocoders that work well over open data for mobile apps. Of course, there's Nominatim, which we're all familiar with. It's the geocoder that powers OpenStreetMap.org. And years ago, I was CTO at MapQuest, and we relied on it heavily. And we hired Brian Quinion, who's the lead developer, who's awesome. And we put a lot of resources into it. And it's been improving a lot, and it's been great to see. However, architecturally, it's not built to handle autocomplete, which is a big use case when you're building a mobile mapping application. So autocomplete is one of the main reasons we decided to do this. And another big focus for us is to make this, personally, I don't think that a single company or a single project is going to solve this problem in the open. I think it's necessary for a lot of different diverse interests to get in. So one of the issues that, when I've used Nominatim is it's very difficult to build. So one of our big requirements here is to make something that's much easier to build. It's not quite there, but we're rebuilding it, and I'll talk about how we're trying to make that a little bit easier. So our goals, we wanted to build this new project that we could provide as a service, similar to how MapQuest provided and still provides a Nominatim service. And instead of building full text capabilities onto PostGIS, which is the way this usually happens, we wanted to start with a full text search engine right out of the gate. And as I mentioned, users expect autocomplete. And so that's something that we really needed to do. Forward and reverse geocoding is very necessary. And we really wanted to make this very accessible for developers, very easily testable. And I'll talk about it in a little bit. We wanted a really modular design to encourage diverse data sets. So OpenStreetMap, we also use Geonames, Quattroshapes. We want to do a lot of different things. So we're using, as I mentioned, Elasticsearch for this. And it was important for us to start with a full text search engine instead of starting with PostGIS. It's a schema-free, document-oriented data store. It's designed for horizontal scale. At my previous startup, we had an Elasticsearch cluster running, I think it was like 6 terabytes, and it performed really well. It has a REST API, uses JSON over HTTP, and includes GeoJSON support. So you can index points, polygons, etc., filter by distance, bounding box, and polygons is quick and easy. So we make heavy use of this in both the build process as well as on the server side. And the most important thing that we get free out of the box with Elasticsearch is a completion suggester that's very fast. It's stored in the index at index time. And very recently, in the latest version of Elasticsearch, they're actually doing filtering by distance. Like previously, you would just type, but it had no awareness of where you were. But in the next version that we'll be rolling out, it'll actually be able to sort autocomplete results for objects near you. So very quickly, for the current version, we're not using OpenStreetMap's admin hierarchy, which Nominatim does. What we're doing is we're taking Geonames, we're indexing this. As you can see, it has country code and admin codes. So we're using that for the admin hierarchy as well as alternate names. And we're using this project you might be familiar with called Quattroshapes. David Blackman has spoken about this from Foursquare at various conferences. It's a set of open polygons, including neighborhoods. It's pretty good that we're using. And it's a concordance both to Geonames and also where on earth IDs. We're using Geonames. We're going to experiment with where on earth IDs in the future too. And then finally, the OpenStreetMap objects. So after we index the entire admin hierarchy, we basically take the streets, addresses, and POIs from OpenStreetMap, reverse geocode them into the admin hierarchy, and then annotate them with that data. So we don't yet support interpolations, but address interpolations, but we will pretty soon. So I actually definitely was too chicken to do a live demo. so we'll see how this works. Okay, so I recorded this last night. The data here is amazing. Germany is amazing. If you guys ever want to move to the US for a little while, you're definitely welcome to come do some mapping there. You can stay on my couch. But you can see in this demo right here, we have both autocomplete and full search happening. The URL is mapsin.com/Pelias. We also have a sweet encoding problem in Germany, which is kind of embarrassing, but that'll be fixed in the next build too. And this is, of course, why so many different parties need to get involved if something like this is going to work internationally. So you can see it has the hotel I was staying at. This is where we went to dinner the other night. So I hadn't pre-tested this, and it works really well here, and also in New York City too. Then I think this is searching for the school we're at. So you can see both search and autocomplete on the right, full text search on the left. And then we go over there. And this is the reverse geocoder. So you can see the target, and as you stop panning, it will reverse geocode. And again, the data is just incredible here. It's similar in New York City, but it's great because New York City came from this building import, and this is really good. So just to talk a little bit about the current setup, we built it several months ago, then rebuilt it twice. The first two versions were Ruby. And there are some problems with the current setup. It's a little bit too complex. There are too many external dependencies that we want to remove as much as possible. Because again, the goal is to get this buildable on someone's laptop and make it very easy to build off an extract and easy to set up, because you don't really want to mess with all these imports if all you want to do is fix a query or add some logic. So basically, the way it's working right now, the service you just saw, we have the admin hierarchy with Geonames and with Quattroshapes. Then we have the OSM data. So we're actually running OSM to PGSQL, putting that into PostGIS. And then we have this other complicated process that uses Redis and Sidekick workers, it's a Ruby background processor that then indexes everything into our Elasticsearch cluster. So it works. It's reasonably fast, but it's definitely not developer friendly. So I hope Andy Allen isn't here because this is going to be awkward. But the new version is actually using Node.js, and sorry. But I actually think it's great for what we're doing. We make heavy use of Node streams. And actually, Peter Johnson is here. I don't know where you are, Peter, but right there. He's been doing a ton of work on this, so definitely hit him up afterwards as well if you're curious. The new version is great. We're basically doing the same process, but with Node streams. So we're actually downloading and unzipping the Geonames and Quattroshapes on the fly. And we're actually, instead of using OSM to PGSQL, we're going right from PDF format directly into Elasticsearch. This isn't quite pushed up to GitHub yet, but it's working, so that's kind of exciting. So the idea is to be able to do this. Granted, running Planet is huge, and you need to do this, with a lot of high-powered equipment. But we really want it to be easy for someone to pull down their own country or region and just be able to contribute to this if they want. And then the other key thing, which is coming with the Node rebuild. So if you go on GitHub, all of our stuff is available on GitHub. So if you go to GitHub, you can check this out. It's not in master of Pelias, but it's in the Node branch, if you want to look at that. But what we're doing is making it very modular. So we have the base module, an Elasticsearch client, the Geonames and Quattroshapes, which provide the admin hierarchy, then the OpenStreetMap, and also a web view, which will replace the web view that I just showed. But one of the things that we really want to do is get to a place where if you just, let's say you just want a geocoder for Geonames for some reason, or you want a coarse geocoder, you can knit together Geonames and Quattroshapes. That'll be very simple. One of the things that we were talking about was, like just supporting diverse data sets. Like what was the project? I forget, was it the fantasy map yesterday? I forget what the name of it is, but Open Geofiction, yeah. When we were watching that, I was thinking like this would be really great to be able to set something like this up to just do any kind of data set you want. So we're moving to that architecture now. So take a look on GitHub and let us know what you think. And yeah, so any questions?